Hello everyone and welcome to Azam Shah Weekly. This video is brought to you by my course Test-Driven Development in iOS using Swift. Now this course is going to take you from start to finish in learning about how you can perform test-driven development when you are using your SwiftUI application. This also covers UI test, test code coverage, mocking, end-to-end testing, unit testing, the domain, interface, integration testing, and a lot more. So definitely check out the YouTube description where you can find the link for this course and check out the course. Thank you so much. In the last sections, you learn about how to write unit tests for your calculator, tip calculator application. Now in this section, you're going to be learning how to write user interface UI test for your tip calculator. And the reason that we are still using the tip calculator example is that I want to show you in a very small steps using a very simple application that how you can begin writing unit test and UI test for a very simple domain like a tip calculator. Once you have established the basic concepts, then we can move to a more complex domain. The first thing we need to do in order to write our user interface test is to add a brand new target. You can see that currently we have two different targets. One is the actual tip calculator application and the tip calculator unit test. But for a UI testing, we will add a different target. So let's go ahead and add our new target. You can see I always forget where the target button is, but here it is. We will go and add a new target. And let's go ahead and search over here for test. You can see that we can now select the UI testing bundle right over here. Tip calculator UI test, that's perfectly fine. Let's go ahead and add that. The reason the tip calculator UI test is separate from the tip calculator unit test is because unit tests that you wrote earlier on are meant to be very, very fast and in memory, while the user interface test or UI test do take a lot of time to run. So you can run it overnight. Sometime even if you want to run it using like every check-in that you do to a code base, that's perfectly fine too in different scenarios, depending on how much time does it take. Integration tests are usually run overnight because they can take a lot of while to run also. All right. Now, if you look at the tip calculator UI test, you will find a couple of different files over here. You have a tip calculator UI test launch test file and the tip calculator UI test. So what we are going to be using mostly will be tip calculator UI test. So now we have added this project. In the next lecture, we will be adding our first UI test. So let's go ahead and see how we can start working on creating our first UI test. All right, so now let's go ahead and begin writing our first test. So what are we trying to test? We're trying to test that when the content view is shown, then we have to make sure that the total text field contains the default value. All right. Now, this is obviously not a test-driven development approach because our user interface has already been done. But we're starting out. It's okay. Our interface is done just like our application was done, but we were trying to figure out how to write the domain, and we created the tip calculator model. The same way, our interface is done, and we're trying to write tests for it. So this can be a great way to learn about the domain, to learn about the application, how it behaves, if you are starting out with an existing project, which is a much higher probability as compared to starting your job or a project which is in a greenfield project, meaning no single line of codes are written. So let's go ahead and first of all, I'm going to delete most of this stuff. There we go. As you have noticed, I like to create my test with a very descriptive name. So the context that we are trying to check is when the content view is shown. Okay, so that's our context that we're trying to figure out. What will be the test? Well, it will start with a test. That doesn't change. You have to have a TEST keyword. You don't really need underscore, but I like to write long function or test names. That's why I try to use underscore. So when the content view is shown, we have to make sure that the total text field contains default value. That's a very long name, but also very descriptive. Just by reading the name of the test, you can actually see what it is doing. When the content view is shown, when the content view is loaded, it's shown, we have to make sure that the total text field contains default value. So just by reading it, it reads like a sentence, right? Okay, so the first thing we need to do is we need to make sure that we are launching our application. Now in UI test, we can go ahead and create an instance of something called XCUI application. This is going to be representing our entire application. We can also go ahead and say that continue after failure to be false. So if there is a failure, don't continue the test, just stop it. And now we can go ahead and say app.launch. So this is going to launch our application. Now, if I don't really do anything and simply go ahead and run the test, you will see that it will eventually launch our application, which will be our tip calculator application that we're testing. And we should be able to see it. Here we go. It's actually trying to launch it. It's not really testing anything at this point because we haven't really written any lines of code to test anything. We are just saying it that go ahead and launch the application. So we're just waiting for it to see if it can even launch the application or not. Now, the first time we're trying to run this test, you can see that it actually started the simulator. So that's why it's taking a little bit of time. But usually also UI tests, integration tests, they do take a lot of while to run, depending on your interface. So you already have seen that if we run the test, it simply launches the application. It's saying that the test has passed, but we haven't really written anything to make it pass or fail. Since we don't really have any asserts in our test, by default, it is just going to tell us that it is passed. So what are we testing? Well, we're making sure that the text field, the total text field, should contain a default value. Default value. Okay, let's go ahead and run this app. Oops, not sure which one is it. Here we go. The default value is enter total, which is right over here. So that's what we are testing against. So we are going to say XCT assert equal. Well, what we're trying to assert is that the thing that will have a value, so over here there will be some sort of a value, and what we're saying is that it will be enter total, exactly like it is. But now the question becomes, okay, how do I get the value from the text box? So this will be the actual value that we have to pass in over here. In order to get the value, we can use the app, which is an instance of XCUI application dot text fields. You can see that you can refer to anything on the screen, text fields, buttons, static labels, pickers, anything you want. And what we're going to say over here is the name of the text field, total text field. And this is going to give us a text field. So I'm just going to call it total text field. Now the question is, well, where are we getting this total text field? There is no such thing that we define, which is total text field. So if I go ahead and run the test, and I say that the total text field that we get, the value of the total text field should be enter total, let's go ahead and run it and see what happens. So I'm going to run it and make sure that we are casting this to string. I'm using exclamation like a force kind of a casting. It's fine. I mean, if the force casting fails, the whole test fails. Let's go ahead and run it. And it actually fails. So it's failing because it's saying that not sure what you're talking about. I couldn't find anything called total text field. So this total text field, the app, which is an instance of XCUI application, it's not able to find any text field where ID or anything has set to be total text field. This means that we have to go back to our tip calculator and to our content view and find the text field. Here's the text field. How do I tell that this text field's identifier is total text field? Well, we can use something called accessibility identifier. So if you search forward here somewhere, you will find accessibility identifier, and that is what you can set as total text field. By setting the accessibility identifier, your test is able to find, here it is, text is able to find the text field. Now if I go ahead and run the application again, the UI is not really important right now. I mean, at this moment, we're not really doing anything with the UI, although we're testing it. We're not really typing anything in the UI. But now you can see that the test is actually passing. So this is great. So by using the accessibility identifier, we're able to run our tests. We're able to get the text field and compare the values. So this is our first test that we have written. So looking at this test, and it is passing, now we will move to the refactoring phase. Looking at this test, can we improve something? Well, it's a simple test. It's the only test. It doesn't really look like we can improve anything unless we write some other test, and we may feel like, okay, now we are duplicating the code, we're copy pasting, so we need to improve it. Now, the second test that we are planning to write is to make sure that when the content view is loaded, the middle option, which is a 20% option, is selected by default. So if I go ahead and show it to you right now, you can see the 20% is selected, which is right there. So that's what we're trying to find out. So let's go ahead and write the test. Test should make sure the 20% default tip option is selected. Very descriptive test name, as you can see. Okay, so in order to run this test, what do we want to do? We want to launch the app. So those 3 lines we have to copy to launch the app. The next thing we need to do is we need to find out that somehow we need to find out that if the middle option is selected or the 20% option is selected. All right. So how do we find out that the 20% option is selected? Now, there are many different ways that you can do this test. You can see what the option is actually saying. So if I go ahead and run it, it's saying actually 20%. This is also index number 1. You can search with that and you can say that index number 1 is basically selected. All right, so whatever the index number 1 is, that is selected. So there are many different ways that we can do that. So the first thing we need to do is to find out how to access even the segmented control. And that will be the important part, because in order to get the segmented control, we will have to use something called app.segmentedControls. And again, I have to pass in the accessibility identifier that doesn't really exist. So I'm just going to say tip percentage segmented control. This is going to give us tip percentage segmented control. Obviously, you can use any name you want for the variable. Make sure that the tip percentage segmented control accessibility identifier is set up in content view. So I'm going to go over here in the content view, and I'm going to make sure that this particular picker view does contain that. So slash accessibility identifier, there we go. Going back over here. So going back over here, we can see that our test is there. All right. If I want to see that if a particular button of a segmented control is selected, I can say tip percentage segmented control dot buttons dot element and bound by, And if I say bound by, we will see that what it actually returns. So if I say element, you can see that it's going to return you XCUI element. So number one, index number one, all right? And this is going to return us some sort of an element. So let's say this is going to return us a segmented control button. It's getting longer and longer. You can see it's going to build it first. Okay. And we can set over here that the segmented control button dot label the text that is being displayed. So first, let's go ahead and write the test so that we can see that the text that is being displayed is something. So xct assert equal, and what I'm asserting is that the text being displayed is equal to 20% for the label. Let's go ahead and do that. Not sure why saying string is unused. There we go. So currently, we are not checking anything that if it is selected or not. We're simply saying that the text should read 20%. Let's go ahead and run this. Because right over here, you can see 20%. And that's what we are saying, that if we have even selected the correct one or not. Okay, so looks like this test is passing. This is great. But this simply says that the segmented control button, which is at the index number one in a segmented control buttons array or the collection, is 20%. It doesn't say anything about that if this is the one that is selected or not. So we can use xct assert true, and we can probably say segmented control button dot is selected. All right. So this is going to make sure that that button is actually selected when application is loaded. So let's go ahead and run this. And it passes. So under what condition this test is going to fail? Well, let's say that somebody goes to our content view, all right? And these are the pickers, right? Maybe some new developer joined in or something happened, or somebody accidentally selects it to right over here on the top, the default value to 0.1. So you can see the 0.1 means that 10% will be selected, and I can go ahead and refresh it to show you that the 10% will be selected now. If you look at the preview now, you can see that the 10% is selected. So let's say that somebody accidentally does that. Now if I go to my unit test and run this test again, this test should fail because the 20% is not selected. It is the 10% is selected, and you can see it is failing. So at that point, we will go back and research that what actually happened. We can't really deploy this application because when the content view is loaded, the 20%, which was the default thing that you must have selected, is not selected. And that is where our investigation will begin, and we will find out that someone has accidentally set this to 0.1 instead of 0.2. So now we have changed it, and now we can go back and run our test, and hopefully that test will actually pass. So this is what the unit testing is all about. It is going to give you confidence to make those changes, and if you mess up those changes, then hopefully the unit test will provide you a net to catch you when you fall. So this is our test. Both of our tests are passing. Now in the next lecture, we'll be looking at that, can we improve this test? Is there a refactoring that we can do to make sure that this test looks nice enough and it is easier to maintain? So let's go ahead and take a look at that in the next lecture. All right, so now that we have written our first two tests, the UI test for our tip calculator, we can sit back and look at some ways to improve or refactor the test. Looking at these two tests, the first one and the second one over here, what do you see as being repeated? Somewhere in the test, if something you see is being repeated, maybe that is a good point to start refactoring. And in our test, you can see that the repeating part is when we are creating an instance of XCUI application and continue after failure as well as launching the actual app. So how can we make sure that we are not repeating this stuff? Now, one of the special functions which is available in XC test case is called the setup function. Make sure that you are not using the class over here. We're not talking about the static or class level setup function. We're just talking about the instance method for setup. Setup is a special function in testing, and whatever code that you type in setup will be fired before running each test. So this means that if you're running this test number 1, first the setup function is going to get fired, then test number 1 is going to get fired. If you're running test number 2, then first the setup function is going to get fired, then test number 2 is going to get fired. So this is a great place to set up some default things. Since for both of these tests, we want to create an instance of the application and we want to launch the application, maybe we can just do it inside setup. So for this, I'm going to go ahead and create a private var app, a property, XCUI application. And inside setup, I'm going to go ahead and initialize this XCUI application. I can also say continue after failure will be false and app.launch. This means that anytime you are going to run any test inside when content view is shown, then setup is going to get fired first. It's going to initialize it, and then you are going to run the test. Since we have moved this code into the setup, we don't really need this code in the test as it is. So we can simply go ahead and delete it. And you can already see that how our test is now becoming nice and small and refactored. Let's go ahead and build it. And let's go ahead and run this. So we have performed our refactoring. That refactoring was just to introduce a setup function which is going to get fired before each test is run. One thing to make sure is that the setup function is not holding any state or anything. So this means that when the tests are running, they are getting a new copy of XCUI application, because a test have to be independent. It doesn't have to depend on the previous test or anything else or outside resources. That's why we're creating instance of XCUI application for every single test that runs and then launching it. Just like the setup function, there is also a teardown function. And again, the teardown function, this one, the one which it comes without the class, without the static. This teardown function is going to be called after each test has run. So after you run the test, it's going to call teardown. After you run test number 2, it's going to run the teardown. So teardown is a great place to deallocate items. Maybe you have added or created some file in the setup, so you want to delete those files. So making sure that you are cleaning up the stuff that you have done, if you have done anything in the unit test or in the web service test, performance test, UI test, or whatever test. So this is a good point to do that. So this is kind of like a cleanup function. Right now, we don't really need to clean up anything. That's perfectly fine. So we're just going to leave it blank. But if you're writing a unit test which creates some files, then in the teardown, you can remove those files. So when you run the second test, it's starting fresh. So that's the only refactoring that we are going to do in our test right now. And the next test we are going to be looking at would be working with when you actually click the calculate tip button. So let's go ahead and write that test in the next lecture. All right, so now let's go ahead and get started with writing our test to calculate the tip once the tip button is pressed. When calculate tip button is pressed. So you can see a very descriptive name, XC test case. Okay. And we can use the same approach of creating a setup and where we can initialize the app. So XC UI application, override function setup. And now we can go ahead and create XC UI application instance, continue failure, false, and also launch the app. App.launch. Great. When calculate tip button is pressed, where our test is, should make sure that tip is displayed on the screen. Now, this test is not really checking for any kind of error input or invalid input, right? It's just saying when calculate tip button is pressed, should make sure that the tip is displayed. So another test we can eventually write is that it should show the error message if the person enters something else, like a -100 or something. All right, so over here, what we are going to do is we are going to, first of all, press the calculate tip button. Now, since our context for our test is when calculate tip button is pressed, we can be sure that for every single test that we are about to write, the calculate tip button is actually pressed. So the first order of business would be to get access to the calculate tip button. And we can use the same logic, app.buttons, and get calculate tip button. Once again, there is no calculate tip button accessibility identifier. We will go back to the content view. And we have to be careful where we are setting up the calculate tip modifier. You can see over here that we are using calculate button over here. And one of the things you will note about this is this particular button is implemented in a little bit of a different way. Because it's a button, we want to put the calculate tip modifier on the label of the button. All right, so let's go ahead and do that. In this particular case, you can see that there is no label. So I'm going to try to find out where we can put the label, because this is what is getting displayed. So we don't really want to do that. So I'm just going to remove that part so that we know that we have actually clicked on the button. All right, so let's go down here somewhere after all the catches have been evaluated, probably over here, and maybe we can add a label, and the label will be calculate tip. All right, and this is where we can go ahead and add accessibility modifier to the label. So a little bit of we have to change our interface to add a different overload for the button so that it will have a label, and that label is accessibility modifier is calculate tip button. Let's go ahead and build it. Let's go back to our UI test. We also need to make sure that we are able to get that particular button. So this button is fine. That should be okay. Okay, so we get access to the button. Now we can say calculate tip button dot tap. So tapping the button. But before tapping the button, it would be a good idea to actually write something in the text field, like an actual total amount, right? So let's go ahead and say total text field, app.text fields, and let's copy the name for the total text field, which is actually total text field. We have already added the accessibility identifier, so it should be able to get it. Once we do that, we will say total text field.tap, because in order to get the text field activated, you have to tap on the text field. Once the text field is activated, we should be able to say type text and I'm just going to type 100, which means $100 is a total, and we press the calculate tip button. Now over here in our test, we need to make sure that the tip that is being displayed is correct. But how do we even access the tip label? If you go to the calculator or the SwiftUI content view, this is the text that is being displayed. So what we need to do is somehow access this text. And once again, we will have to put accessibility identifier on it. There we go. So this text is identified by tip text. So let's go back to our test, and we can update our test to access that. So probably we have to wait for existing or something. So let's go ahead and say tip text app.static text, because it's just the text being displayed on the screen. All right. And now we can say tip text dot wait for existence. Wait for existence basically means that we are going to specify a little bit of a time to wait, because it takes a little bit of time for the text to be updated when you click a button. So we will wait for, let's say, 0.5 seconds. And then we can say assert equal and tip text dot label, the actual text will read. And what will it read? We can go ahead and say something like $20 or something. All right. Let's go ahead and build it. All right. Let's go ahead and run this test. Basically, we are saying that if we put $100 in the total text field, we click a button, then we should see the tip being calculated and displayed on the screen saying $20. Let's go ahead and test it, but I'm just going to go ahead and click on this test, and we will see that simulator is going to launch. It's going to enter $100 in the total text field. It's going to also press the button for us, and then it will see what's going on. There we go. And the test actually passed. All right. Well, there we go. I mean, we wrote a test and it's actually passing. So that's actually pretty good. You can see that we learned something new about testing, which is that you can type in the text field. You can actually tap on the buttons. So you can kind of automate everything related to your user interface. All right. Now, in the next test, we are going to look for a different scenario, that when the calculate tip button is pressed, an error message should be displayed if the total was wrong, if the total was invalid. So we have to still write that test. Let's go ahead and write it in the next lecture. All right, everyone. So now let's go ahead and move to our second test when the calculate tip button is pressed. And the second test is basically testing that the error message is displayed on the screen for invalid input. And the invalid input can be if you are entering the total as a negative number. All right. So let's go ahead and get started. I'm going to go ahead and say test should display error message for invalid input. Now in this test, we have to do quite a bit of things that are similar to the previous test. This includes getting access to the total text field, tapping the total text field, writing something in the text field, and then pressing the button. Now, having said that, one of the things that will change is that we will not be entering 100, but we will be entering a negative number, let's say minus 100 or minus 2, minus 5, whatever. So that causes a particular part of a problem. Because if I simply go ahead and use the setup function in this case, the setup function is indicating that this particular test is going to be using 100 as a value and not minus 100. So there are multiple ways of solving this problem. One of the ways is that you can create a separate test case for the error that you're going to receive. And the second way is that you can simply copy this code into each test. I know it kind of like sounds that we are just copy pasting, and we are, but I'll show you a different way that to minimize this copy paste effect later. And then the same thing we can do over here. All right. Now, when we do that, we can go ahead and change for the negative number. We can go ahead and change this to a negative 100 or negative 10 or whatever you want. The next thing that we are going to be doing is we will get access to the message text. So let's go ahead and do that. Message text equals to app.staticText message text. We are just going to make sure that the message text actually appears. Sometimes it can take a little bit of time for it to appear, so we're just going to wait for 0.5 seconds, or even you can do 0.25, quarter of a second is fine also. And then finally, we are going to check the same thing that we're checking over here for the tip. We are going to check that the message text label is saying invalid input. Now, keep in mind that there is no such thing as message text, so we have to go back to our content view. And for the text, which is right there, we're going to set the accessibility identifier to message text. Let's go back. Let's go ahead and build it. And now we should be able to run the test. Let's go ahead and run the test. Enter some invalid total like negative 100, and then see that if the message is saying invalid input. Oops. Where is it? Here it is. Okay, so the test is actually passed, so that's great. All right. Now, obviously, you can add some more tests over here also that should display error message for invalid input. It is displaying error message for invalid input. We can also, you can write another test, which can be test should clear the tip label for invalid input. All right. And you can already see that I'm just going to copy paste all of this stuff. Don't worry, we're going to clear it out. Don't worry. All right. So over here, I'm just going to make sure that the tip label is actually cleared out. So I'm just going to go ahead and get the tip label. We will order the tip text. We're going to wait for existence. And then we are going to say the tip text.label is going to be empty because hopefully it has been cleared out. If it was not cleared out, it has been cleared out. Let's go ahead and run this test again, or this new test. And this test is just checking that for the invalid input, the tip label has been cleared out. And that test is also passing. All right. Now, all of these tests are around passing, that's fine, but there's a lot of stuff going on, a lot of copy pasting that we did. And at this time, when we're copy pasting it a lot, it still works, but our test should also be in a good condition. I mean, we can definitely refactor this test. One of the ways we can refactor, as I mentioned earlier, is by saying a different context. So we can actually say when calculate tip button is pressed for valid input. All right. So that can work. So when calculate tip button is pressed for valid input, which is valid total text field, then we should be only running this particular text. Oh, not this one, the first one. That's the valid input, right? And this means that we should be able to just copy paste all of the stuff over here. So you can see that we are making sure that we are putting the test under the correct context. Now, the another one can be when we are setting up, we can set up when calculate tip button is pressed for invalid input. And all of our other tests can actually go right over here. So we are going to copy the setup, all of this stuff, that's fine. Go ahead and add invalid input. So I'm just going to say -100 just to make it easier. And we can copy these two tests, cut it, and put it in its own context. And we will remove all of this stuff because this is already happening in the setup. Let's go ahead and remove it. And now you can see that your tests are a little bit more cleaner, and they also provide a different context. This context, the first one, is a context if you have a valid input, if everything was going fine. And this is for invalid input when everything was not going fine. All right. And let's go ahead and run for this invalid input test. So I'm going to run all of them just to see that our tests are passing. Both of the tests are actually passing. So here we go, invalid input. The first test actually passed. And now it's running for the other test. And looks like the second one also passes. Now we can go back to our when it is for valid input to see if it calculates the total correctly or not. 100 is fine, $20. Okay, looks like everything is working fine. Now at this point we are done. We have all the tests and everything is working fine. One of the things that you will note over here is every time we want to access a text field, every time we want to access a button, every time we want to access some sort of a static text, we have to put the names over here, right? And these names are now spread out in our tests. They're everywhere in all of our tests. For this, or to make this problem under control, we can make use of something called a page object pattern. The page object pattern, which we will learn about in the next lecture, allows you to create a page object that can represent all of these different UI related elements, which can consist of the pickers, which can consist of the labels, text fields, buttons, all of those toggles, everything. And then it will be much easier for us to use. So let's go, and in the next lecture, we are going to learn about how we can create and utilize a page object pattern. Now, one of the ways that we can improve readability of our UI test is by introducing page object pattern. The page object pattern is going to allow us to create a separate class for a particular page that we're testing, which in this case will be content view page. And it will have properties that will allow us to access different elements on the page, like text field, the tip button, the text, and so on. So in our UI test, let's go ahead and create a brand new folder. We will call it page objects. In this folder, I'm going to go ahead and add a new file, and we will call it content view page. Great. So this will be our file that will represent a content view page. I'm going to go ahead and add content view page, and this is only for testing. This is not going to be used in your actual tip calculator application. I'm also going to go ahead and import XCTest. In order to access different elements from this file, someone needs to pass in an instance of XCUI application. This means that we will have an initializer that takes an instance of XCUI application. We can say self.app equals to app. So in order to create a content view page, you must pass an instance, an object of XCUI application. Now we can go ahead and start exposing different properties which will return us the different elements on the content view page. So let's go ahead and get started with the total text field. This is one of the elements on the page, and we're going to be returning XCUI element. App.textfields. And now we can pass in total text field. So you get the idea that the content view page is using the page object pattern. It will consist of all the properties that we are using that can allow us to get access to the different elements on the screen. So I'm just going to go ahead and add a couple of more, like calculate tip button. I will go ahead and also add the tip percentage segmented control. And obviously you are free to use any kind of a name that you like. I'm just using a little bit more descriptive names. And we should also have an access to the tip text, right? The text that will be displayed indicating the tip. And also probably the message text, which is XC UI element app.static text. This is where you will display the error message if there is any error message. And this is going to be our content view page. Now we can go back to our code and we can start looking at where can we introduce the content view page. All right. So the first thing we need to do is to make sure that we are creating an instance of the content view page. So I'm going to go ahead and put it right here in the test, var, and I will call it content view page, which will be of type content view page. And I'm putting an exclamation mark over here, force unwrapping, because it needs to be populated or else it will just blow up, which is okay. So I'm going to say content view page equals to content view page. And in order to create content view page, I need to pass in the app, which I'm doing. Now let's see that how it makes our life much easier. So I'm going to go ahead and remove that. And instead of the content or the total text field, I'm going to say content view page dot, and I think it already has total text field. So there we go, total text field. So we can simply use that. Much nicer, right? I mean, you can see that we don't have to refer to the text field again and again. And the same thing can be used for anything basically. All right. So in order to get some other thing, we can go ahead and say content view page dot tip percentage segmented control, and we can even get access to the button. So over here we can say tip access control button on the page. There we go, control. So we don't even need this line now. All right. And you can just go ahead and start replacing all of these different things. So if I have to do the same thing for another test, since the another test or the different test is using the same exact content view page, actually that's the only page we have in our application, I can simply create an instance over here for that, passing in the app. And now I can use the same exact technique. So let's go ahead and do that. So over here, in order to get that, we can simply say content view page dot total text field, and we can get access to the text field. Once we have access to the text field, then we can go ahead and tap it and we can type the text. The same exact thing we can do over here. We can say content view page dot some sort of a button, probably calculate tip button. There we go. For a tip text, we can say content view page dot tip text. And the same thing for the other text. All right. So you get the idea. The whole plan of using the page object model is that if something happens and somebody goes and say that, hey, instead of calling it the message text, we should be calling it the error text, then we don't have to go through all of our tests to make that change. We can simply go to the content page and update it over here. Instead of message text, we can say error text. And all the different places where we have used this, it will be updated automatically. All right. So this is the real benefit of when you are using the page object pattern. And that's it. Now we have learned how to write basic UI tests for our SwiftUI application, which tests tip calculator application.